Today we are going to read and highlight the lessons in light and communication, which is Unit 9. If you scroll down to the table of contents, you can see that there's only one lesson in this unit, which is called Communicating with Signals. Make sure that you have the highlighter section up, and sometimes remember that we'll use the drawing tool to identify key diagrams that are important. Communicating with signals. Sailing around the world. When Abby Sunderland was 16 years old, she tried to set a record. She wanted to be the youngest person to sail alone around the world. Abby began her journey on January 23, 2010. Her boat was named Wild Eyes. She began in Marina del Rey, California. In March, she became the youngest solo sailor to round Cape Horn. Cape Horn is the southernmost point of South Africa. Sending a distress signal. On the morning of June 10, 2010, Abby ran into trouble. There was a major storm. It produced 9-meter or 30-foot waves that damaged her boat. Abby was more than 3,218 kilometers or 2,000 miles from shore. She was in a remote part of the southern Indian Ocean. All of Abby's regular ways of communicating were damaged. To communicate means to share information with. She couldn't use a radio or phone to let anyone know she needed help. At that point, Abby turned to her emergency beacons. The beacons communicated Abby's location in the ocean. As a result, a search and rescue team was able to find Abby's boat and rescue her. Signals transfer information. Beacons work by sending distress signals. A signal is an action used to communicate information. There are many different kinds of signals. If you wave your hands in the air to get someone's attention, you are sending a signal. Many signals use patterns to transfer information from one place to another. Remember that patterns are things that happen in a regular and repeated way. For example, if you send 3 of any signal, it means you need help. This could be blowing 3 short times into a whistle, or it could be turning a flashlight on and off quickly 3 times. 3 whistle sounds or 3 flashes of light are codes. A code is a message communicated with a pattern of information. Symbols, letters, words, sound, light, etc. Morse code. People use different systems for communicating messages over a distance. One of the longest lasting systems is Morse code. Morse code is a way of extending text into a series of dots and dashes. To encode means to turn information into a format or code so it can be easily and/or securely transmitted. To transmit means to pass on from one place or person to another. For example, with Morse code, each letter of the alphabet and number is represented by a sequence of dots and dashes. The dots and dashes can be transmitted by pulses of light, on-off tones, or clicks of sound. When another person receives the code, they have to decode the message. To decode means to turn coded information into a form that can be understood. Morse code isn't used as often as it once was. However, it is still used in some situations. SOS remains the most common distress signal. It is recognized around the world. SOS is represented by 3 dots, 3 dashes, 3 dots. Don't forget to highlight or make a mark next to that diagram. Air traffic control towers use signal lamps that use Morse code. These signal lamps are a backup. They are in case a plane's radio stops working. Sailors in the Navy also sometimes use signal lamps to communicate in Morse code. This is especially useful when there is a need to be silent. Sending messages with light. Light can be useful for sending messages because it travels faster than sound does. Like sound, light is a form of kinetic energy. However, unlike sound, light doesn't need a medium to travel. It can travel through a vacuum. A vacuum is a space with no matter. All light needs a source. There are many sources of light. The sun is a source of light. So are flashlights and signal lamps. Light travels outwards from its source. It travels through space in a straight line until it interacts with matter. Almost all matter reflects some light. To reflect means to bounce off of the surface of an object. That is how we see. When light reflects off an object and into our eyes, we see the object. Make sure that you draw a star next to this diagram. Digital signals. In addition to Morse code, both light and sound are commonly used in more high-tech forms of communication. When you speak into a cell phone, you produce sound. That sound travels outward in sound waves from your mouth and into the phone. Your phone then encodes those sounds. It does this by converting sound waves into digital signals. In any digital technology, information is translated into a countable set of numbers. These numbers are most often ones and zeros. So here we can see an example of a sound wave being converted into ones and zeros and how much of it, the highs and the lows. Morse code is a good way to understand how information can be turned into a digital code. People often called Morse code the first digital code. This is because it has two states, a dot and a dash. Both Morse code and digital code are binary. This means they use two symbols. Morse code uses dots and dashes to represent letters of the alphabet. Digital code uses ones and zeros. Different kinds of information can be represented digitally. Your computer turns letters into codes of ones and zeros. Each letter is represented by a pattern of ones and zeros. Similarly, pulses of light or sound can be represented digitally. For example, a pulse on can be represented by 1. A pulse off can be represented by 0. So we see some examples here, and it's hard to tell the difference, but there is a difference between the combinations of ones and zeros. When you speak into a phone, the sound of your voice is turned into a digital code of ones and zeros. Your phone uses pulses of light to send that digital signal to a cell phone tower. The tower receives the signal. It then sends the signal onto the phone of the person you're talking to. Before that person can understand your message, it has to be decoded. The digital code is changed back to sound waves that the person listening can hear on the other end. And again, we're going to star this diagram at the bottom of the page. A rescue in the ocean. Abby's emergency beacon transmitted information in a similar way. When Abby used her beacon in the middle of the ocean, she sent a digital signal. Her beacon had a specific 15-character digital code. This code was unique to Abby's beacon. The beacon transmitted its digital signal to a satellite orbiting Earth. This satellite then transmitted a signal to stations on the ground. These stations could direct search and rescue teams to Abby's boat. Digital signals are useful because they are a reliable way to send information. They can carry more information than non-digital signals. They are also more accurately decoded than non-digital signals. Make sure you have everything highlighted that needs to be highlighted, and then move on.